We often think of black holes as the ultimate cosmic destroyers, immense vacuum cleaners of the void, relentlessly pulling in everything that strays too close. They are painted as the final stop in the universe, a place where matter, light, even time itself come to a definitive and terrifying end. This image of an inescapable prison from which nothing can ever return has captivated and frightened us for generations. It's a powerful, dramatic narrative. But what if it's only part of the story? What if these cosmic enigmas are not just about endings, but also about new beginnings, acting as gateways to unseen corners of reality? Perhaps they are cosmic bridges, connecting distant regions of our own universe, or even linking our reality to entirely different ones. This idea transforms the black hole from a mere destroyer into a potential portal. Falling into one might not be the end of your journey, but the start of an unimaginable new one. A passage to a place governed by laws of physics we have yet to dream of. This concept isn't just science fiction. It's a possibility that emerges from the mathematics we use to describe the cosmos. Could the most destructive force we know also be a creative one? The universe is more elegant and surprising than we give it credit for, and black holes may be its greatest, most beautiful secret. So let's embark on a journey to explore this possibility. We'll peel back the layers of mystery surrounding these cosmic behemoths, starting with their violent births and moving toward the very edge of the unknown. To understand a black hole, we must first witness its creation, a process born from the death of a truly colossal star. For millions or even billions of years, this stellar giant burns with incredible ferocity, fusing elements in its core and pushing outward with immense energy. This outward push from nuclear fusion is in a constant, delicate battle with the inward pull of its own tremendous gravity. But like all stars, this giant must eventually run out of fuel. When the fusion in its core begins to falter and die down, the outward pressure vanishes in an instant. The star's core collapses in upon itself with catastrophic speed, triggering one of the most violent events in the universe, a supernova. While the star's outer layers are flung into space, the core continues its relentless collapse. Gravity, now completely unopposed, becomes unimaginably powerful. It squeezes the remaining matter of the core into an infinitesimally small point, a singularity. The fabric of space-time itself is warped and torn by this incredible concentration of mass. It's at this moment, from the ashes of a dead star, that a new cosmic entity is born. A stellar mass black hole, a permanent scar on the universe. Every black hole is shrouded by an invisible boundary, a line drawn in the very fabric of space-time. This boundary is known as the event horizon. It's not a physical surface you could touch or stand on. Rather, it's a theoretical line that marks the point of no return. At the precise location of the event horizon, the escape velocity becomes greater than the speed of light. And since nothing in the universe can travel faster than light, anything that crosses the event horizon is trapped forever. From a safe distance, watching something fall into a black hole would be a truly bizarre experience. Because of the extreme gravity, time itself appears to slow down. To you, the distant observer, it would seem as though your friend's spaceship was slowing to a crawl, getting dimmer and redder until it appeared to freeze just at the edge. But for the person inside that spaceship, their own clock would tick normally as they sailed smoothly and irrevocably past that invisible line. The event horizon is a one-way door in the universe. It is the cosmic veil behind which the greatest secrets of the universe are hidden. Crossing it means leaving the observable universe behind for good, a boundary separating our known world from a realm of unimaginable physics. If you were to fall into a black hole, the journey across the event horizon might be deceptively calm, especially for a supermassive one. But what comes next is anything but gentle. As you continue your descent toward the singularity at the center, you would encounter a process physicists call spaghettification. This process results from an extreme tidal force, a stretching caused by a dramatic difference in gravitational pull over a short distance. Imagine you are falling feet first toward the black hole. The gravity at your feet, being slightly closer to the singularity, will be immensely stronger than the gravity at your head. This difference begins to stretch your body. It starts as a subtle tug, then rapidly intensifies into an irresistible force. Your feet are pulled away from your head with increasing violence. At the same time, gravity from the side squeezes you. This stretching and compressing leads to the spaghetti effect. Your body would be elongated, drawn out into a long, thin strand of atoms, like a piece of spaghetti being stretched until it breaks. Every single part of you, from your bones to your cells, would be pulled apart. It's the complete and utter obliteration of form. Once an object has been spaghettified, its constituent atoms have crossed the event horizon. What happens next? According to our current understanding, all that matter continues its journey toward the singularity. At the singularity, the laws of physics break down completely. Our theories of gravity, quantum mechanics, cannot describe what happens there. It's a point of infinite density and infinite space-time curvature, a true dead end for our science. Or is it? This breakdown has led some physicists to propose an alternative. What if the singularity isn't an endpoint? What if it's a gateway? This idea comes from general relativity. Einstein's equations permit a theoretical opposite, a white hole. A white hole would be a region of space-time matter can only exit, light can only exit, never enter. A cosmic fountain spewing out energy and information. This suggests a wormhole, an Einstein-Rosen bridge. The singularity might not be an infinite point, but connect to a white hole elsewhere. The black hole as entrance, the white hole as exit. The tunnel could connect two vastly distant points in our universe, a shortcut across billions of light years. Black holes might not be prisons but cosmic transit systems, connecting the dots of the cosmos in ways we are only just beginning to contemplate. For so long, our story of the black hole has been one of pure finality. It is the ultimate endpoint, the place where stars, planets, even light go to die. But as we've explored, modern physics invites us to look beyond this bleak picture and consider a far more profound and hopeful possibility, rooted in creation as much as destruction. In this view, the black hole is not a grave but a womb. The matter and energy it consumes are not lost forever but are instead recycled or repurposed. This perspective aligns beautifully with a recurring theme we see throughout the cosmos, cycles of death and rebirth. Stars die in supernovae, but their scattered elements form the basis for new stars, new planets, new life. It seems almost poetic that the most destructive force in the universe could also be a creative one, a mechanism for cosmic renewal on the grandest possible scale. So, the next time you look up at the night sky and contemplate the darkness between the stars, remember what might be lurking there. Think of them as mysteries, as puzzles, and as possibilities, reminding us that in this vast, wonderful universe, an ending might just be another name for a new beginning.